Hey everyone, how you guys doing today? So I think that previous video didn't work out because it doesn't work out for me. I felt like I was just consuming content, and just like kind of reacting to content kind of thing. Um, Even though it was Khan Academy and like I might refer to Khan Academy videos in the future as well. Khan Academy is awesome, but I'll do it in a more deliberate way, right? Because I think I have been like espousing creativity and learning new things, but I think one thing is nice to have that anchor point of that thing you're trying to work towards. Is like for me, I'm trying to make a video, which is also like, yes, I want to do that learning process thing, but also come up with an end wherein I am actually, what's the word I'm looking for? Actually, producing a piece of work that explains this mathematical thing, um, which in this case is eigenvectors and eigenvalues, in code, right? That's the whole shtick. That's what I want to do, uh, and that's like fun for me. That's what I want to do on the channel, and that's what I've been finding is actually really motivational to be working towards. So that's awesome. I'm getting right into it, and I wasn't like I I hate to be a shill for ChatGPT, but uh, I feel like it is nice for this and being able to call upon like really rich text explanations that's tailored for your level of understanding. And I'm just hoping that the reasoning models have been trained highly enough that uh that this is accurate, but also like I've said in other videos, it's like it's not a bad place to start, but make sure you explore and go in other places because I bet it would give me, especially for this stuff, because it's fairly early on still, and it's kind of lame that I don't know that much. um it should be pretty decent on even the lower tiers, and like no matter what, it's at least a starting point to go forth and start asking questions otherwise. Anyways, so I just asked it to explain eigenvalues and eigenvectors. Like, what are they? Like, that's like the core issues. Like, I'm seeing all these things about how you find them and this and that. But what are they, right? And let's see. I'm just gonna read this in my mind. I What was nice is like earlier before I started the video, I like highlighted this and it gave me that Ask ChatGPT thing, and I asked it like, how do you say this mathematical notation? And it actually gave me the answer as expecting. I didn't realize I'd be able to do that. So that was kind of nice in terms of learning. So it's A is an element of R to the n by n, or more completely, it's A belongs to the set. So I'm going to just redo that just to see if I can do it blind. So A, just by looking, like I'm just going to stare at the formula and nothing else. So it's A is an element of R to the n by n. Okay, so that's this thing. Or A is belongs. Oh man, I gotta read the full thing first and then do it again. Meaning A is a real value matrix with n rows. So one of the things I feel like that stops me from reading more higher level papers is not like necessarily the math they're doing. Just I feel like the main issue is not knowing the notation, so it takes me a while to understand the math. So I think that's one thing I should practice during this process. So I'm just gonna okay, I'm just gonna like look at it for like a second. Okay. Did a couple of dips, but all right. So A is a real matrix with n rows and n columns. Oh, A belongs to the set of all n by n real matrices. There you go. Meaning A is real valued matrix with n rows and n columns, right? Like this is the more formal one, and this is the explaining one, right? A belongs to the set of all m by n real matrices, or just saying that A is a real valued n by n matrix, meaning it has n rows and n columns. Um, so if it's n by n, so A is a square matrix, I'm guessing. I don't know if that's needed to get eigenvalues or eigenvectors through the matrices need to be square. Yes, for a matrix to have eigenvalues and eigenvectors. So it's the concept of eigenvectors and eigenvalues is tied to the idea of linear transformation that maps a vector onto itself. If the matrix is not square, just by the way, everyone, I'm just like rereading this section like over and over again and just trying to picture it. I'm gonna wear my AirPods because there's some background noise happening. I don't know if you guys are picking up because I set the mic to voice isolation. Just checking if the cursor is being recorded. I want a more formal definition because, like, I mean, I know linear transformation is, but I'm just gonna still see a more formal function. Oh, it's three blue, one brown. That's funny. I like three blue, one brown. Oh man, I don't want to turn this into another content reaction video. But I do like three blue, one brown. You know what? I am trying to understand linear transformations. Fuck y'all, I'm
All
watching three
line
blue, one brown. He's like amongst my favorites. Guys, go. The wrong thing though, I think I've done it. Why is like try to consume less content. So you know what? Actually, now let's not do that. we have to preserve vector addition and scalar multiplication. And I know essentially a transformation is that it moves that vector in that vector space, right? It's a function between vector spaces that preserves. Let me see if I can. Georgia Institute of Technology. 500 internal server. Fucking hate that shit. Okay, I think this is a. I think this guy might be right. I don't think this one's useful. Close that. And sometimes I just vibe it when like this is something either like this is just wrong. Sometimes I vibe things are wrong, and I felt like the guy was just having the overthinking thing, and like the Reddit guy also said that maybe it was the chicken and egg. Maybe I saw that post, and then I'm like, oh, maybe this guy's overthinking it. I don't know. The guys hear noises, just like I said, doing more vlog style stuff. This is kind of boring, I know, but that's kind of what this is like sometimes. Gotta embrace the boredom, let your mind wander and stuff. Like I'm reading but not reading. That happens. Ah, okay, I think I get it. It's between two vector spaces, and that was kind of like my major malfunction with this one over here. It's a function between vector spaces, right? But here it's mapping, right? That's essentially what it is mapping between two vector spaces, right? You have an initial vector space, because that's what I imagine transformations as. And that's why I was like, well, wait, what? That's why that thing wasn't clicking for me. And I think it was just worded maybe a little bit too unintuitively. And usually Wikipedia is the one that's not intuitive. Or maybe I'm just trying to start to understand. Who the fuck knows? Uh, I'm just a pleb, probably. Between two vector spaces that preserves the operation. So it's essentially an operation or a mapping between two different, and that's the thing, like the vector spaces have to be different, right? Because, that's my realization from like my previous videos on working on the Gram-Schmidt orthonormalization stuff was that the vector space is the space spanned by a vector. Like, how can you move this vector, right, in this space, right? And two dimensions, that's like the if I have a vector u, that's 1, 1, right? That's like both the unit vectors added up, so I plus j. Or if you have both of those added up over here, right, that can span this entire line of y equals x, right? It can, that's the vector space for that vector of the unit vector summed up, right? And it's obviously like in three-dimensional space it's different, and then obviously in n-dimensional space it's just not something you can actually perceive. I'm sorry if you guys are picking up a lot on the mic. I hope it doesn't become too much of an issue. Also, a laptop batteries. quickly draining. I'm gonna plug it into my power bank, like a really nice one that does 140 watts out. So seriously, I'm super happy about that. It's like the most like anxiety improving or like digital age anxiety improving product. Anyways, whatever. Not gonna be a show for power banks. Okay, so going back to that initial thing, the concept of is tied to the idea of a linear transformation that maps a vector onto itself. There's scalar multiple of itself within the same vector space. Okay, so it's the mapping of a vector in space. So 1, 0, like one transformation is if you just rotated that all the way back onto itself, or it does something crazy and comes back onto itself. Um, Something like that, right? Basically, that's what this relies on for some reason. Eigenvectors of a matrix are vectors that, when multiplied by the matrix, result in a scaled version of themselves. The scaling factor is the corresponding eigenvalue. Okay. Shouldn't there be multiple eigenvalues and eigenvectors? Can you not have multiple eigenvalues for each vector? No, okay. So that was me, like I was just thinking like, okay, does this mean that, well, literally this, right, can like, because if it's just about scaling this and mapping it onto a scaled version of itself, right? Does that does that mean like, is it like as the set of all of them? No, it's not like the set of all transformations, because going back to the unit vector thing, it's not about just this, right? It's like can do this as well, but there's some specific transformation. An eigenvector is a non-zero vector that, when transformed by a matrix, only changes in scale, is stretched or shrunk, and the amount it's scaled by is the eigenvalue. If a vector were scaled by two different amounts by the same matrix, it wouldn't be an eigenvector for either of those scaling factors. Okay, so there's a matrix, right? I mean, that's like sounds like a revelation, but there's a matrix. Yeah, okay. So we need to have a square matrix, A. Think of square as a linear transformation that takes any vector x and maps it to a new vector ax. Oh, well, okay. Well, it does say settings, so that does make sense. Sometimes I just ignore pieces of things, but it's good, like, jumped around coming back to this. Okay, so most vectors change both direction and length under this transformation. Okay. So the matrix A is the definition of the linear transformation. Can I think of it like that, right? So I have some vector x, like let's just say 2 by 2 a b c d, right? And x y ax equals b, some output vector, right? Ax is first value in the first column, second value, right? So you'd have an output vector in that situation. So I'm picturing that matrix. Maps to a new vector, AX. So A multiplied by X, right? I think this would mean that the matrix would only be filled up in the diagonals, right? Because if you're scaling it, you'll scale the first element by some value, right? So if it's like a 3 by 3 and 3 vector, so the 2 and the 3 can't make any effect, like each one. Let's test that. Linear does a linear transformation matrix up is a matrix linear transformation only filled in the diagonals. Oh, matrix that transforms the vector onto itself. Yes. Okay. That's important. Because obviously any transformation could be. Yeah, okay. So we have, oh, where to go? We don't want to look at my Trello. Okay. Because I thought I was, like, started watching Khan Academy again. So I was like, and now this is too contenty, not really thinking about it, which is fun. Okay. So this this is just like a general thing of like A is a matrix that is a linear transformation that takes any vector x and maps it onto a new vector ax. An eigenvector of A is a non-zero vector v, so this, such that when you apply A to V, the result is just a scaled version of V. The scalar is called the eigenvalue associated with that eigenvector. Okay. Okay, that's making sense. I'm hungry too, boys. Let's try and go for a little bit longer. Let's be daring. Sorry, I got distracted by watching a moth outside. Okay. AV equals lambda V as A minus lambda I. Does lambda I work? I don't know. What are the defined operations in matrices actually? It's not 100%, so let me just think through if this really works. Then maybe we can actually look up what operations are defined and how so. The lambda I makes sense to me, right? Because then you get exactly the same vector back, right? Because if you do, wait, lambda is not, no, I'm stupid. Lambda is the vector of eigenvalues. Sorry, right? Multiply that by, no, wait. Oh shit, wait. Yeah, lambda is just the eigenvalue, scaled version of V, an eigenvector of A. So an eigenvector of a linear transformation, essentially, which is a real valued matrix that's only filled in the diagonals, is a non-zero vector V, such that when you apply the linear transformation A to V, the result is just a scaled version of V, right? The vector V scaled, right? So V is a vector, lambda is just an eigenvalue. So A minus lambda I is just A minus this is just like element-wise operation, which has to be defined for things with the same shape, I'm guessing. I mean, how else do you subtract and add matrices? I don't know of any way to see how that's defined in a situation where the matrices are not equal. Okay, so this makes sense. So, okay, yeah, right, because I is the identity matrix, which is, I'm presuming, the same shape here. V equals 0, okay. For non-trivial solution, where V is not equal 0 to exist, the matrix A minus lambda I must be singular. Okay. So wait, non-singular, non-zero determinant, unique solution. Okay. Okay, so to find eigenvalues and eigenvectors, you have to have a singular matrix. Okay. For non-trivial vector eigenvector to exist. Sorry. Expanding this determinant yields a degree n polynomial in lambda. Okay. So polynomial is like an equation, right? It's like a squared plus bx plus c equals something, right? Yields a degree n polynomial. A, n is n by n, okay? A degree n polynomial in lambda, the characteristic polynomial. Its roots are eigenvalues, are all the eigenvalues. I want this to expand on this, please. Hmm. I'm gonna ask how to say this. How do you say this out loud? P of lambda. Oh, that's just P. I thought that was a rho. RHO, some Greek symbol. Never mind. P of lambda equals the determinant of A minus lambda I. P of lambda equals P is a function, right? Because that's, oh boy. Oh, this guy wrote a lot. Let me try to understand this. Got 15 more minutes on my power bank, but it's doing a beast of a job. Gotta sit up in my chair a bit. Oh boy. Ooh. Okay. Oh, it's literally called characteristic polynomial. Okay. So since A minus lambda is an n by n matrix, diagonal entries are AII minus lambda, and off diagonal entries are AIJ. Expanding the determinant gives you a polynomial of degree n negative lambda. Okay. Just gonna trust that this makes sense, right? Is there an example? Hmm. Okay, it's actually getting a bit difficult to read. Brain's just having trouble in processing. I think I'm just a bit tired and hungry. I think I'm gonna call it for this video right now. But based on how I'm feeling, I might just pop off another video later today. But this was nice. I think should keep doing this, right? Focused on like the actual process of learning. I very clearly realized though that this video format is not really fun for someone else to watch, really. But um I think it would behoove me to maybe get a video editor or something like that to cut this into like the parts of me talking and thinking and all that jazz and like maybe make a couple of memes out of it. But regardless, if you're watching, thank you so much. And remember, just keep the curiosity alive. I hope I'm proving that. And I guess I think the other thing to important is be able to accept boredom and not understanding things. Um, the joy is when you get to the other side, and is what most people think. But I actually feel like eventually you start cultivating this sense of like, oh, that feeling of mystery is the fun part, right? Once you get over that egoistic part of yourself that's telling like, yo, you suck, you don't know what you're talking about, you're never gonna get this, and you just like once you do it a few times, enough times to talk back to that side of you and say like, no, fuck you, I understood that thing, you know. just skip the self-doubt phase and just be like, okay, this has to make sense. The world makes sense of it. So I'm going to sit down and make sense of it. Anyway, thank you all for watching. Have a great one. Bye bye.